Welcome back to Demystify Sci. I'm Shiloh.
I'm Anastasia.
Today, we're following up on some interesting comments that we've been receiving regarding our last conversation with Michael Lachmann about the origins of life. And a lot of people are like, why does it matter? It's obvious what life is. And we're like, that's a really good question. And the answer is convoluted and it will hopefully lead us somewhere really important. And so we decided to peel it apart today.
I think the bottom line is that we think we understand what life is. And we should be suspicious of our immediate response of, well, duh, life is obvious. Because the true story of it might be far more complex. And if we can properly understand what we think of as life, if we have some kind of higher level definition for it, then we can look out into the cosmos and we can start to ask the question of, what else is alive?
How unique is it, actually? What else is alive? Where might life be happening that we're not looking? We're just looking under the lamp, but there's stuff outside of the halo. So yeah, it's really important. And if it's so obvious, why does NASA's definition for life suck so bad? That's another really interesting question. So we're going to tear all that apart. I will lay it out for you. We will be exploring this incredible book, which is from 1937. It's called Star Maker,
Here, let me hold it.
where Olaf Stapledon explores a fictitious exploration of the galaxy across vast eons of time and imagines that life is happening at different scales. And it's a really beautiful book. I only had time to read one excerpt of it, but if you haven't read this thing, I mean, Arthur C. Clarke said that this was the most important work ever. And I believe, who's the Lion, Witch, and the Wardrobe guy? C.S. Lewis was really pissed off and said this was essentially the work of Satan. So from whichever angle you're interested in, I think it'll be it's worth checking out. I would highly, highly recommend it. It's very, very beautiful, poetic exploration.
The opening page has a bunch of quotes from Arthur C. Clarke, Jorge Luis Borges, Doris Lessing, Virginia Woolf, and H.G. Wells that are all like, this is the best book that's ever been written in sci-fi. And granted, a lot has happened since it was written, but I think it still holds up, and it's a really excellent.
Yeah, it's hardly a sci-fi book either. I mean, it is. I can see that, but it's more of this meditation. It's just a guy's daydream, essentially. He like goes outside and takes a nap after he has a fight with his wife, right? And he just has this vision of how everything works all at once. And, you know, today you might try to cram that into a scientific theory or something of consciousness or a theory of stellar life cycles or something, but he just put it in a work of fiction. And so we're going to be bringing that into the conversation today. I think you guys are going to love it. Tell us what you think. I'm really curious if our definition set for life is amenable to you. And
if you like what we do, consider supporting us on Patreon. We are exclusively supported by our patrons right now, and we want to keep it that way. We don't want to have advertisements or sponsorships because we really believe that making stuff as a vehicle for slapping advertisements on it is a paltry way to live. We want to make something that is deeply appreciated by the people that we produce it for. And so if you like it, come over to patreon.com because that is the most direct way that you can show us. If you do not have any cash, that's totally fine. We appreciate it when you like, follow, subscribe, when you tell your friends about the podcast, when you talk about the ideas in the podcast with people that you know. You can also follow us on Facebook, Twitter, Instagram, TikTok, basically anywhere where there is a social media. I think we're on LinkedIn as well, which is absurd completely.
every day.
Shiloh maintains that. So
I mean, just keep podcasts not trashy, right? I've noticed this tendency, you guys probably have too. Like, ad content is on the rise. Like, podcasts I started listening to 5 years ago was like one little set of ads at the beginning. Everybody just put more and more and more. And it's funny because when podcasts started, everybody was like, yeah, we're like getting away from mainstream news where you have to cram a bunch of information between ads. And I'm like, guys, you're headed that direction again. We're just reinventing the wheel. So let's keep it real. Let's keep this entirely about the content. And the only way that's going to happen is if you support the creators you care about.
We also have t-shirts for sale, and we have conference tickets going on sale for our Portugal conference in June of next year. We have a bunch of cosmologists. It's going to be on the subject of crisis in cosmology And it's going to be a 3-day workshop where we talk about the history of cosmology, the giant problems that it is facing, and lay out a roadmap for some future solutions. So keep an eye out for those. We have some really fantastic names, which I am not willing to announce quite yet, but in the next few weeks, we will make an announcement, and it is very, very, very exciting.
Limited tickets on that one. I think we're going to keep it to like 50 people or something.
Yeah.
So block off your calendar for June 12th. That's the weekend. And by the way, if you sign up and become a patron, you will have first access to those tickets.
First dibs.
So anyways, I'd love to see you there. I'd love to see you at our weekly patron chat. And I'd love to hear your thoughts about this conversation. So talk to us.
For now, enjoy. We'll see you next time.
The scientific revolution starts now.
This is the Science Joy Podcast.
Let us see in the dark.
What are the categories of things that you have ideas about?
Well, we just had this really interesting and positively contentious conversation with Michael Lachmann about the origins of life, and it got us rethinking about something I think we got into a while back, which was the idea that life may exist at different scales that we can't perceive. And then you gave this lecture yesterday at university about the origins of life, which kind of terminated in the same idea. And we did explore it a bit with Michael, but I felt like our ideas were a little bit too compressed about that. And so...
And on top of that, people in the comments were like, why did you guys spend so much time dealing with the definition of life? It's obvious what life is. Just move on. And I'm like, I think that actually warrants a lot more discussion and thought, because we don't actually have a way of creating life, quote unquote. And we have a very different relationship to things that are living versus things that are not living. And so all of our moral structures are kind of centered around this idea of living versus non-living. And so if we can actually work out what a functional definition is, we might actually get closer to generating life in a way that everybody agrees that it is life. And we might get closer to having a decent moral framework for interacting with nature in a way that's much more encompassing than the one that we have right now.
It seems like it's really important in terms of solving a huge problem that we're facing right now, which is that science doesn't seem capable of attending to people's human needs the way that everyone hoped that it would in the future. And a huge part of that is reconnecting to the cosmos and reconnecting to nature and to the universe that we're part of, which isn't just atoms, right? There's atoms, but there's also something else happening.
Yeah, it's really interesting because when I was giving this lecture, I was looking through all the old graphs for the organization of beings on Earth. So phylogenetic trees. Lamarck was making them. I think Haeckel was making them. There's a guy named Groch who I found who actually came up with the first idea of the tree. And every single time you look at one of these trees, at its apex is a human being. And we've moved away from that in some way where people don't really say it out loud that often, that they still think that humans are at the apex. But I do think...
I hear that all the time. I hear that from the AI type people all the time. I can't remember the last time I heard it, but all the time.
Okay.
Elon,
I think there's a certain subset of people who still think that humans are at the apex, but then there's another group of people who are like, hey, I think that it's weird to talk about apex when you come to realize that humans can't exist without any of the other creatures.
Not only that, but the bacteria seem to really dominate more ecosystems than humans do, right?
And they've gone much farther in reshaping the face of the earth over the course of its existence.
But they're primitive, man.
Right, exactly. So, but the reason that I bring this up is that I'm like, when you put man at the hierarchy of all beings, I think that removes a lot of this divine nature from the cosmos.
Yeah.
Because you look around and instead of seeing divinity everywhere in the trees and the bugs and the bacteria and the stars, you just see man striding across an empty cosmos where we can do whatever we want. And When has doing whatever you wanted ever proved to be a good thing?
Yeah, it's not just divinity too. It's also just integration and like seeing the forest for the trees kind of thing as well, right? Seeing yourself as a part of something larger, but also something ever present and everywhere, and seeing yourself reflected in the nature that you encounter. Before we get too far past this, I wanted to re-emphasize what you said about us not having a definition for life, because I think part of the comment section was, we already know what life is, right? The funny thing is that NASA has a definition for life. NASA's definition for life is a self-sustaining chemical system capable of Darwinian evolution. So you're like, okay, well, fair enough. What's Darwinian evolution? Darwinian evolution is a theory of evolution by natural selection that explains how organisms adapt. Okay, what's an organism? An organism is a living thing, blah, 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 blah. Okay, that's about as circular of a definition as you can get. So living systems are characterized by this thing that living things do. It's like, wait, what? How does that make any sense?
And it's so weird, right? Because this is the epitome of you know it when you see it. Because on Earth, I remember researching this a little bit, where I was like, have we ever had a period of time where philosophically we had a difficulty of telling things apart that we're alive versus not alive? And it's, from my very cursory search, it seems like no. There's always this thing where you can see something that's alive. For example, the closest that I could get to it was teeth. People used to think that teeth were dead. They look dead. They look like they're just pieces of stone in your mouth, right? And at some point, I guess they can rot, but dead wood can technically rot as well.
I thought you were going to say rocks can rot for a second.
I was I was moving in that direction, but I decided against it. So, okay, teeth. That's maybe one of the only things. But even fingernails, they seem to grow. And there's this development. And so we don't have a problem with looking out into the world and being like, alive, alive, dead, alive, formerly alive, never alive. And so it's really funny that when you come down to it, you're like, okay, well, what makes something alive? What makes it contain the properties of life? No one can actually really pin that down very well. People are literally arguing about it in philosophical journals and biological journals. Did you just have a fighter jet pop up?
Yeah, Facebook's, my computer's overheating big time. This computer is going to die soon. Yeah, so it just started scrolling on its own. Yeah. I wanted to make sure I have that picture later, because that's going to become important.
Yeah, of course. So we have the sense that we know very clearly what is alive and what isn't alive, at least on the human scale, right? We can touch things.
Let's pull that apart a little bit.
Okay.
So what is it? What is it that you see? I mean, one thing that's obvious, one way you know something's alive is if it starts moving on its own, which is interesting. Now, we're going to run into problems with that when it comes to robotics and, rivers and stuff like that. Another way is that it seems to devour stuff, and in the process of it, make more of itself. But the same thing could be applied to different chemical reactions or lava, right? So it gets, lava chews up, it flows down a hill and sort of eats towns and stuff like that. All right, so it consumes, it moves.
But you were saying it consumes and makes more of itself. And so lava actually only goes downhill, literally.
All right, so we can rule lava out based on that definition. So it consumes and makes more of itself. Now, the tricky thing about the makes more of itself is
there's not a lot of stuff that does that. This is why reproduction is so central to the definition for life in most sources. I think that...
But a child wouldn't look at something that was alive and be like, oh, it's making more of itself. Like it sees a dog or something, right? Or it sees a tree.
I think that at some point, kids actually did. I think that we have such a weird urban life right now that our separation from nature is so complete. But if you think about a kid, the kid would watch the dog have puppies. Yeah. The kid would watch the trees sprout fruit, and then the seeds would be planted. It's like
that would be part of their understanding of what a dog is.
this generative process. And we live in such a sterile world, right? Our fruits don't have seeds. The stuff that you buy at the grocery store does not have seeds that you can plant. The animals are all spayed and neutered, and so none of them ever reproduce.
But reproduction alone is troublesome because you do have self-replicating systems that we wouldn't consider alive.
Like the kind of like algorithmic computer games?
No, I'm thinking of like molecular stuff like ice that can nucleate and spread under the right conditions.
Well, which
it can
is
create more
why-
crystallization in general.
I was going to say crystallization, but which is why they always tack on homeostasis to the back of this definition whenever it's a listicle, because it's not just that you can reproduce, it's the fact that as the environment around you changes, you can maintain your internal state in such a way that your nucleation can continue. Because ice is screwed when the temperature gets hot. But if ice was able to forcibly maintain a stable envelope for a wide range of temperatures and maintain its crystal state, then we could talk.
Interesting. Okay, so we're getting a little bit closer. So life is animated, although the timescales might make it difficult for you to see that in the case of like a slow growing bacterial film or something like that. Like these archaea, what are those things that are the desert varnish? That's probably not a good example because people argue whether that's alive or not.
That's actually really crazy, right? Because desert varnish is one of those things, another one of those things like teeth that people look at and they're still actively arguing about whether or not it's alive. It's widespread, people study it, and they cannot come to a conclusion about whether it's just stuff being leached from the rocks and having living objects deposited on it, or if it's actually alive in and of itself. No one knows yet.
I think really like big trees are a good example of something that's not obviously moving, that's alive still, obviously. That's really interesting, right? So, you go and observe some object in nature and you're like, is this alive? You can't just use motion, right? Because you could be standing still too. I mean, obviously, if you got under a microscope, you'd see a lot of motion, but it does seem like even the word animus, right? The animated entity, we do have an aspect of motion to being alive, but it's not the whole story, right? It's bound off in the environment. It's maintaining its form across time.
Well, imagine I think time is really important. Imagine that you had a perfect reproduction of a tree made out of plastic. You walk up to it and for the first moments, you might be like, wow, that's a really extraordinary tree. That's definitely alive. But then you watch it for long enough and you realize that it's not actually responding to the environment. It's not changing its leaves. It's not growing seeds. It's not flowering. It's not going through the cyclic process that all of the other trees do.
It's not adapting.
It's not adapting. It's not changing. It's just this inanimate object that slowly degrades over time. You'll probably see it degrade.
There's something about pushing back against the environment, right? That is what you're circling around with, this boundary idea that you isolate yourself from the circumstances that befall you to some extent, right? Enough to be able to persist and obviously regenerate.
Which is why old age and death are the loss of your ability to do that. You slowly break down, you slowly fall apart, you slowly lose your ability to push back against the environment, and the environment encroaches on you more and more until you desiccate, and then you're in the grave.
Yeah, I had this revelation during your lecture yesterday where you were talking about life being far from equilibrium. And I was like, yeah, like equilibrium is just you dissolving. It's like a homogeneous soup of everything just being completely mixed up and chill. It's like equilibrium's very blah.
Like a dam is at equilibrium technically, but it's a dynamic equilibrium, right? You have the water up above, you have the river down below, and there's a specific flow rate through the dam that is maintained by the engineers inside of the dam.
In other words, it's a controlled disequilibrium.
Yeah, so when we talk about stability at a distance from equilibrium, like I'm thinking about those reactions that go from the clock reactions. Do you know what I'm talking about?
Yeah,
the chemistry that changes color over time when you mix
it. This is like Prigogine books.
Yeah, Are those states that are on either side of the pendulum swing considered equilibria?
I think that's just bistable equilibrium points.
So okay, a stable equilibrium of some kind.
Yeah, but like when I think about life, like your dam analogy is, I think, valuable, especially when it comes to understanding metabolism. You essentially have this huge imbalance set up in the case of charge, right? You set up a battery essentially between the air and your food supply, and you have this battery going, right? This huge imbalance of charge or voltage or however you want to think about it. There's an electrical imbalance, and it's really, really hungry to equalize itself, right? Because there's all this tension in the universe all of a sudden. And so life is this process by which it is managed. That tension is managed and used for motive power, reproduction, assembly, all of these things that we consider part of what it means to look like a life form.
Yeah, it's the process of harnessing the environment.
Harnessing that tension, right?
Yeah. As you're talking, I was thinking about something that I didn't get to in the lecture, which is that life, this dam analogy for life and this river analogy for life makes a lot of sense. Even if you, and the way that it's applied in modern life is that you have these mitochondria or you have these bacteria that are producing ATP by creating this gradient, right? So you have hydrogens in a reservoir, you drop the hydrogens down, and then you generate this molecule that you send all over the cell that's able to be used for work. But that's a really crazy system. It has a bunch of proteins, it's electrically delicate, it has all these iron sulfur clusters as reaction centers that are enveloped in these huge bodies, and the final molecule, the final protein in the process, is this molecular machine, right? It's a ratchet that's actually that's actually just grinding these phosphates back onto these depleted
molecules. That's really
molecules.
similar to a hydroelectric dam.
Except
it's not hydrostatic pressure, it's osmotic pressure.
Yeah, but the point that I'm trying to make is I think that the system probably developed much more simply, where there's something that's called substrate level phosphorylation, where if you have a catalyst, you can take something and use that catalyst to do the same work without using the dam. But, nerd, what it is that like instead of having this mechanical complex dam structure where you have a turbine and the turbine is doing some work, you have an enzyme or you have a surface that is reactive. It acts as a catalyst. And so you can have the depleted molecule, and when it interacts with the catalyst, without any dam metaphor, without anything else, it just interacts with the catalyst, and if there's enough free phosphate around, it'll spin it onto the depleted molecule.
Okay.
But you still have to have a flow. You still have to harness a flow, because what do we know about chemical reactions? It's that they stop if the products build up. And so something has to constantly be carrying
that
away.
tension, yeah.
Yeah.
That's what I love. If you read Tesla's original writings, he refers to voltage as a tension, actually, which I think is really, really important for understanding it.
So does Faraday.
Yeah. Okay.
And Faraday was obsessed because he could never find any sign of it. I think he might torsion might have been the word that he used.
Really?
Yeah.
Interesting.
I know. I ran across it. I was reading a biography of Faraday, and the guy looked through all his journals and picked out the details. And Faraday was just obsessed because he was like, it has to be some sort of twisting, torsional thing, but he could never experimentally prove it.
Interesting.
Isn't that great?
But I just can't think of a better word than tension, because that's our human analogy, like tension release. Like you wind something up and it's able to do motive work. It really contains this potential energy concept in a really nice way. And so I think that's what we're talking about, harnessing in all of these cases. And so then, I don't know if we're ready to go there yet, but the question becomes, what other tensions are there in nature where you might expect to find life, perhaps at different scales as well, right? Because the problem with our definition for life, what I was trying to point out before, is that we're only thinking about organisms in the classic sense of these lipid-bound cells with nucleic acids, which are essentially coding the replicative information. And you have something which, under our present conception, represents a robot with a computer system encoded in DNA. And that's all well and good, but I think that a really robust scientific definition shouldn't be limited just to what we see on Earth. It should be limited to the defining characteristic of what we see with life on Earth, which seems to be the harnessing of this tension for productive replication, motive power, stuff like that. And so where else might we observe that if we actually had a really good definition of life? We might be able to see that kind of processing happening in the cosmos elsewhere, perhaps even at scales on our planet that we're incapable of imagining right now. Because the scale system for our life on our planet extends as small as bacteria, and it extends as large as, these giant mushrooms that you brought up, these giant aspen groves. That's interesting. That's in the right direction. But the only way that they're recognized right now is by their genes, right? So it's still an organismal, biological, terrestrial conception, which is in some sense very anthropomorphic, right? Because we're looking for life based on what we are, and we know we're alive. So the question is, if we have a good definition for life, and I'm not sure that we have one yet, although we've been towing around something that's kind of interesting here about the harnessing of tension for motive force. But
I think that the harnessing of tension for fulfilling your desires.
Ooh, desires, good Lord.
But I think that it's a useful system of thinking, a useful frame for thinking, because then you don't necessarily have to have cells or DNA or anything else. It's just this foundational process where you take the physics and the chemistry and you bind it towards a thing that life seems to do, which is evolve. And evolution can either be brainless, just whatever gets knocked down a hill, or it can be directed not by the environment purely, but directed by the choices that a creature makes within the scope of possibilities that lay before it. Because I'm like a deep believer that even the bacterium makes a choice.
Yeah, sometimes you make the wrong choice and that's it for you.
Yeah. But so tension harnessed for the manifestation of desires. And what you're saying is that, okay, we can look at the planet, not just things that have DNA, but we can see what else is operating in this framework that could be life-like. And
yeah, sorry, I need to just soak in the choice making for a second.
Okay.
And that's really profound if it's true that all life is in the process of making choices at all times. I haven't heard that as a definition for life.
Interesting.
I
feel like I'm like banging on about that all the time.
No, I know, but something about the way that the way that you put it in terms of choices is something really interesting because, computer gates are switches, but they're passive switches, right? They're not making choices. The input user is making choices. And this is why I always stall out with these AI researchers and so forth. Is they're like, I'm really afraid the thing's going to get sentient and stuff. And I'm like, is it making any primitive just show me one glimmer of a primitive distinct choice, like interest, that it's making. And maybe those do, we're going to have more of those conversations. So I'm open to being convinced that's happening. But for me, that's kind of at the essence of what makes something aware. And awareness is at the heart of you saying that it has will. It's like, well, what's the difference between awareness and will? Not too much, really. It's like, you perceive something's happening and then you move based on it. You make an action. Whether it's moving your little flagella towards some other tasty chemical or, deciding who you're going to hang out with, just picking your friends or whatever, making mate selection. There's choices that are really at the heart of this. So, reproducing chemical reactions, I don't like that part of the definition that NASA has because I think can be applied to things that are clearly not alive. And then the Darwinian thing is, again, circular. So anyways, this choice making and using naturally occurring tensions in nature to power the choice making is really, really exciting to me.
And I think that Lachmann's thing about functional information also plays a role here, which I don't totally know, which is that if you're making choices, you have to have some kind of motivation for those choices. And that motivation requires you to have some set of facts about the world, right? Like, you can't really make a choice if you have no idea what the landscape looks like, if you go towards this chemical or that chemical. And so the things that we recognize as life are those that are making informed choices. I mean, all of this is really nebulous, right? Like, what does it mean to have an informed choice?
Especially as a bacterium.
Right. And so I think that this is where this starts to get difficult, which is why we don't have a really satisfying definition for life, which is that how fine are these gradations? Do we need to have, it seems like you need to have information if you're making choices.
I think you do. I mean, I don't think that you could just say bacteria are randomly walking and stumbling into success or failure. Like, maybe at some primitive point in time, if we start to really push on the origins of life and the emergence of the first bacterium, we might see something closer to that. But today, the bacteria have these entire libraries of information about how they should be behaving.
Yeah, they have information about everything.
We all do. To some extent, like, we know how to breathe.
And
we don't have to think about that when we're born.
And so the primitive life forms that preceded whatever was the first bacteria-like creature on Earth had to develop some of this informational framework in order to even get to the point of being a bacteria. Because I think that there is a conservation that's also included in this, where it's like, if too much changes from generation to generation, it can't really grow and develop. You can't really, I think, get a functional organism if every single generation just looks completely different. The likelihood that you will change too much, too fast, and just end up destroying the entire thing seems like it's pretty high, right? Because in order to harness tension, you probably have to have a relatively robust system in place that lets you do that.
All right, remind me where we're at with this. So we're harnessing tension for motion towards reproduction and thrival. There's a choice-making ability that appears in living entities. What was the first piece that we came up with?
I think it was the tension. No?
There's one other thing.
Information?
No, that's one of the first things that we announced. Maybe it was just motion, but damn it. Well, it'll come back to
I think
me.
that it was change. There was the idea of change, the response to the environment.
Oh, yes, that ability to separate yourself from the natural equilibrium, right?
Mm-hmm. But that, I think, is tension, because tensions tend to be really transitory.
I guess that tension in the respiratory chain is artificially constructed.
Yeah.
So the tension is actually created. It's not just that you're harnessing a tension that's naturally occurring. You're actually creating a tension in order to harness it.
That's what I was saying. Like, in the
Creation
lecture, I
of
was
tension.
like, they're like little hydroelectric dams or chemoelectric dams that they've created. And it's interesting because we've never actually seen these proteins work. And so as I read this stuff and I refresh my memory about it, I'm reminded of a feeling that I always had, which is that this is the equivalent of us looking at Mars and being like, man, I think that Mars is green sometimes, before we sent rovers there to really see. Like, all this stuff is so small. You can't really see the ATP being created. You can't really see the protons falling down through this ATP pump. You can't really see any of this. It's below the wavelength of light. There's no microscope that lets you see a proton.
Yeah.
There's no microscope that lets you see an ATP molecule.
Do they crystallize them or something and do X-ray scattering and
Exactly. So you isolate that, you break apart the cells, you open up the proteins, you crystallize them, you then do X-ray diffraction, you reconstruct the structure. They'll crystallize them with the molecules in the pockets where they're supposed to be, and with water in the main channel, and with protons in the main channel. So they're able to, like, kind of see the way that it works, but It's really delicate. It's really not seeing the way that we see something on the street or on the tree, or photographs when we actually arrive on Mars and discover a desolate planet.
So we have a system that sets up tension to power its motive choice. Its choice of motives, right? Its choice of motion, its will.
Yes.
I'm still a little uncomfortable with it.
I think it can also passively harness it. I don't think that it necessarily has to build it in and of itself, but if you want something that has staying power, it probably does have to build.
I think it does. I think everything does. It does assemble this tension, or at least it amplifies it at the bare minimum. Maybe the proto-organisms didn't, but
yeah, so basically it has to find a way of carrying with it this machinery or maintaining its environment so that the tension remains, because if you cannot bolster yourself against the changing environment, you're going to die really quickly. And so even if you do come into existence, you will exist for only as long as that tension is in the environment. And it might be that you need the tension to exist for so long in order to really approach alive that no system can make it that fast, right? Like tensions just come and go in the environment. They don't stick around for 4 billion years in the exact same state, or 1 billion years, or 500 million years.
So the $1 million question is, using this generalized definition for life, which is still a little bit of a listicle, but I think we could cram it into a sentence if maybe we'll try to put that on the table after we get done here and put it into one sentence. But we use this definition for life. Where else in the universe, either terrestrially, in the solar system, in the cosmos, might we be already observing the creation of tension, which is used for motive force? Are there potential blind spots where we could see some collection of entities motivating action as a result of the production of some tension? By the way, there's another interesting aspect of life maybe we should deal with, which is that life seems to always involve more than one entity. It's the community aspect to it.
Yeah, like it's hard to imagine a single life form.
This is always the pushback against the Gaian hypothesis. This is actually the most reasonable pushback I've ever heard about it, because obviously the Earth seems to function as a superorganism on, if you zoom out and think about all of the interconnected systems, and we need the oxygen from the trees and blah, blah, blah. But we never ever see life forms, organisms existing in isolation. There's always at least two, usually a greater community of organisms. And so the question becomes, well, and they're usually in communication, either chemically or audibly or with light. So the question becomes, is there a community of these Gaian planets that are actually in communication? Is that even possible?
I mean, we're talking about a 4 billion year arc.
That's
right?
the hard part.
And so if you were looking at a tree that took 4 billion years to go from seed to fruit to seed again to complete one cycle, how would you even really be able to track if there's communication with other trees over the course of that enormously long period of time if you were hampered by your own lifetime only being 80 years?
I mean, I think this question would be really easy to solve if it turns out that, the UAP community is right and we've been being visited by intelligent life, right? I mean, I know that sounds a little silly in the context of this conversation, but the minute that you have NASA saying that we've detected signs of life on another planet, how many thousands of years is it before we go there? And then how many, and then at some point it's like, okay, these planets are actually in communication. That's one way I can imagine it. when
Radio communications should work over long distances, though. So you should be able to communicate with people that are really far away at light speed if you came up with some kind of laser that let you send a really powerful signal, right?
You should. So we haven't seen any of those to my knowledge.
I think the WOW signal could
Wow,
plausibly
signal's
be
interesting.
that.
Yeah.
Where I'm like, I think that this is the thing. If you were a civilization that has the capability of sending a long range radio transmission of some kind, I think that it would be really wise to be careful because you don't know who's out there. And honestly, first contact is extraordinarily dangerous. Like, I am fully willing to open myself to the idea that if an alien civilization did come to Earth, that it's possible that they would infect us with some kind of super virus, the same way that when the Europeans first arrived to North America, they infected the indigenous tribes with some kind of super deadly organism. I'm like, what viruses have formed on the planets of Alpha Centauri that we've never seen before? Because they've had some innovation where it's like, I don't know, they have, instead of keeping mammals inside their houses, they keep reptiles in their houses. And so they have like weird reptilian viruses that we're not immune to.
Yeah, I mean, assuming, like, obviously disease is the biggest killer when it comes to contact. That's all of, 1491, Charles Mann's book, right? But there's also the aspect of cultural infection too, which is something, I wanted to bring up Olaf Stapledon here in a minute, and I guess it's as good a time as ever, but he's written this incredible book, which is essentially this hallucinogenic dream this guy has. No drugs involved, but he has this dream one night that he's transported out and makes contact with these.
He has a fight with his wife and then goes outside and goes to the stars.
It's like, and he makes contact. Eventually, he's led by different guides through the star systems, and he's given access to this telepathic communication ability, and he can eventually zoom out and see time happening really, really fast. And amongst other revelations at the end of the book, and I'm going to read some passages from it because it's just an incredible, incredible vision for 1937, right? It sounds so similar to something from like Abiogenesis or something with the Galactic Federation, right? But this is from 1937. And at the end, he's talking about this giant battle that essentially these higher order organisms have to step in and intervene against, because it's essentially these replicator species that are colonizing the galaxy and trying to essentially force their culture onto all of the other star systems that it visits. And the higher beings determine that this is not healthy. Right? They determine that a vibrant ecosystem should have all sorts of life experiments going on, and not just this one super centralized bureaucrat. Like, it's almost a mythology of our times in a way, right?
Fantastic.
Because that seems to be, and these people coming back from these DMT experiences talking about Ogi or not just Ogi. He's not DMT. Who am I thinking? Andres Gomez Nielsen put this really interesting model of we're like, Andres, what have you learned from all of your research on DMT patients and your own experiences? And he's like, well, there seems to be this cosmic battle between these personalities, let's say, that want to make everything the same as them, and these somewhat more meek personalities that just want to explore and experience. And you can't really understand it in a rational way.
I just had this realization as you were saying that. Keller is saying the same thing about order and chaos inside of organizations.
Oh, yeah. The stagnation problem.
Right, where you get too much order and it just clicks everything into this immovable structure that nobody can make their way around. And all innovation progress dies. And he's like, nobody has figured out how to stay at the peak of chaos and productivity. Everybody, once they have some amount of order, continues the inexorable slide towards more and more and more and more order. I think that that's something to do with human nature. That I don't totally know how we could get around, because I feel like replicators are everywhere. You see this on the left, you see this on the right. People want the world to look like what they believe the world should look like. There's nobody who's like, hey, why don't we just give everybody the rights to their bodies and ensure that they have a world to live in where they can explore that and figure out how to live well? Everybody on either side of the aisle is basically like, well, let's give people the right to their body in this really narrow sense that tickles the subconscious tribal drive. And the other side says the inverse of that. And so they're just replicators. They're just like, everybody should do the thing that I say is the good thing to do, but not anything else.
Yeah, the hypocrisy is just nauseating at some point. It's like, oh, you care about life? How about you make fast food illegal? Like, how about you, stop? How about you make alcohol illegal? Like, how about you make cigarettes illegal? Like people are getting killed all the time by this stuff. It's like, oh, you care about bodily autonomy? How about you make drugs legal? They're like, whoa, 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 whoa.
Yeah,
well, hold on now. People can't just be killing themselves with drugs.
But this is what I mean about bodily autonomy and replicators being everywhere. There's just, everybody is so comfortable with this idea that the way that life is meant to be organized is just according to some frame of what is acceptable. And anything that deviates from that isn't okay. Everybody is really weird and squidgy as soon as you start to live a non-normative life, whether that's because you don't do a 9-to-5, or you structure your relationships in an unusual way, or you partake in vices or whatever else. It's like we don't really have the ability to really incorporate radical worldviews unless they come at it from a core principle of do your own thing. And so it makes sense that in Star Maker, you have somebody stepping in to be like, no, you can't take over.
Yeah, do your own thing in so much as it doesn't hurt anybody else, right? It seems like that's something like a 2-year-old could come up with. It's just so bizarre that that's not just the foundation. I mean, in some sense, it kind of is the foundation of law, but it's really gotten hazed over to the point that you point this out to people and they're like, whoa, that's really crazy. And you're like, is it? Is it that crazy?
So there's some tendency for replicators to take over, where you just have one vision of the world that becomes mandatory. And it seems logical that that's a disaster.
It's also a strong compulsion for a lot of people, right? I think for all of us, to some extent, is to get people on our page. Isn't that the essence of communication in some sense? Like if you think about two atoms communicating through light, they're trying to relieve some tension and equalize the tension, like equalize their effort in some sense, right? Something about...
But you can do that in two ways, right? You can do that in a way where both of the atoms end up vibrating at the exact same frequency, or you can have them vibrate at a harmonic frequency, where they're not identical and they're exchanging information, but they're not, they're maintaining their unique identities. And I think that that's actually the goal of communication. Because I think that if the goal of communication is to make everything the same, then you end up in a landscape, that you end up in a replicator landscape. The goal of communication, I think, is to understand where the other person is coming from, to harmonize with them, to be like, this is how these pieces fit together. Because I think that the alternative lends itself to homogeneity.
Yeah, it's also, you can have really good conversations with people you disagree with, and you don't ever get on the same page necessarily, but you can still understand your own ideas. Maybe they've found, I think you can understand yourself even better through that, right? So you don't have to get everybody on the same page to have productive interaction.
I would go so far as to say that the more interesting conversations are with people who you don't agree with.
100%.
And I don't, by the end of the conversation, want the person to agree with me. I want to understand where they're coming from so that I can fold it into my library of ideas where I'm like, okay, so this is how I see the world. This is how they see the world. And then make some synthesis where I take the best parts of the way that they see the world and update my own view so that it's some blend of the previous two, as opposed to just being like my view onto the worlds at all costs. Like,
You can see where your own reasoning breaks down too, which is quite useful.
Yeah, all the time. Like that's the whole point, is to see where things fall apart.
So, $1 million question. So, where else in the universe do we see this production of isolated tension, the creation of some tension, physical tension, in service of motive force towards choice making and replication and sustained form? Where else in the universe might we find that? And obviously, Olaf Stapledon is like, hey, the stars themselves, actually. And so I think I brought this up on that conversation with Michael Lachmann, and it was a very quick tour of the idea, but I thought I would take the opportunity today to substantiate it a little bit better and maybe show some pictures, plus read some Stapledon, because he does an incredibly poetic job of persuading us of the possibility of this idea.
Let's do it. Yeah, so this is something that you've thought a lot about, much more than I have. And I think that when you first started talking about it, I was a little, I don't want to say skeptical, but I wasn't sure of how to fold it into this idea. And so I appreciate the opportunity to hear where you're coming from. So when we talk about the stars being alive, our definition for life requires tension and action towards a motivated desire.
Production of tension.
The production of tension. And what I've seen in stars is I've seen some semblance of communication, but I haven't seen the other stuff. And so do you think that you can make the case that the other stuff is there? Because if we've defined that as life, then we have to start, and we haven't even included communication.
I think that I can experiment with some possibilities
Okay.
for the production of tension. But I think that our understanding of how stars do their magic is woefully inadequate at the moment. And I can justify that in some sense because we have this gaseous plasma depiction of how stars work, except it doesn't seem to be working out at all when we try to do that on Earth. And so the basic idea, of course, is that fusion...
But that shouldn't be that surprising, right? Because stars are big, and if they're not that big, then they don't do the same thing, right? Like you have to have a star that's a certain size in order to fuse, right?
You have to have sufficient pressure, temperature regime going on in order to pull that off. The weird thing about that is that when we think about really high pressures on hydrogen in any other body, like in Jupiter, we assume that Jupiter actually has created a kind of liquid metal inside of itself, not a gas at all, right? I don't know if you've seen these, there's a Jupiter mission going on right now, and the evolution of the concept of what Jupiter's material phase has ballooned. It's just blossomed in recent years. I came across a picture the other day where it's basically showing liquid metallic hydrogen at a very reasonable depth, let's say maybe like a fourth or a sixth of the way deep from the apparent surface of Jupiter, right?
Have you sent this to Pierre?
No, but I'll get to it next semester when we start talking about stars. My point is that this gaseous understanding that we essentially got from Eddington 100 years ago is woefully inadequate. And so how in the world exactly stars are powering themselves is tricky, right? Fusion does give you power, and there may be it's hard to imagine a better place for fusion to be happening than inside of a star, especially, the fact that they seem to have hydrogen and helium in abundance, especially ours. It's like, well, you smash two hydrogens together, you get a helium. Like, it makes sense there should be fusion happening there. You need a way to power, you need a way for these things to generate all this light and heat, and you can't just do it through compression like a piston engine. It would burn itself up in a few millions of years. So it needs some sustained reaction. But the intricacies of that may be the missing tension maintenance system that we are searching for in this conversation. Now, right.
Like
so Pierre actually talks about lattice confined fusion as being a promising approach towards artificial fusion here on Earth. He also talks about it as being a completely reasonable way that you could have fusion occurring in stars, assuming that stars are not unique in the physical universe and also at the same pressures that we would expect to find liquid metallic hydrogen on Jupiter. We see those at a reasonable depth on the sun as well, and you have the ability for layers to confine lighter elements that could be fused together. So you essentially sandwich elements between these sheets of metallized or sheets of hydrogen lattice, and you can squeeze them together through different forms of pressure. Whether in the laboratory they use lasers to squeeze these layers together. In the sun, of course, you have not only gravity, you have electromagnetic pressures, you also just have radiation pressures. All this to say, in a long-winded way, that there is a maintenance of a structure that seems to power the sun. The search for how the sun is powered is one of the biggest debates in all of astrophysics.
Which is funny because it's so close, relatively speaking.
Yeah, it's right there. But people couldn't figure it out. There's huge raging debates, right?
And I guess is the marker for being able to figure it out the ability to reproduce one in the lab? Because it seems plausible that we'd never be able to make one on Earth.
Make a star, no, but we should be able to demonstrate the mechanism if it is so simple. And I think that the early studies by NASA out in Cleveland with lattice confined fusion are also demonstrating that fusion's possible through this mechanism. So fusion's possible not in any usable gains so far, but we've demonstrated it's possible through lattice confinement. We've demonstrated that by magnetic confinement of gases, it's also possible. The question then becomes, are there other mechanisms? And which one of these makes the most sense given the phase diagram of hydrogen for a star?
So confinement and tension then seem to be sort of two sides of the one coin. Where on one hand you have tension, which is the creation of these differential reservoirs that have some kind of pressure between them, osmotic pressure. And here we're talking about confinement pressure. So it seems like the pressure is really the thing that you're harnessing. And it can be either, because you say tension, but what does tension really mean? Tension, when I think about it, is like you pull a rope and there's tension. Is pressure similar to tension?
Tension, it is. Actually, tension is literally defined in physics as negative pressure. So it's just a directionality. It's like, which way does the vector point?
Interesting.
Yeah.
Really? They have the same math?
Yeah.
That's fascinating.
Yeah. So when you talk about surface tension, it's just negative pressure, or tension monomers, it's just negative pressure. But
okay, so tension and pressure are two sides of the same coin.
Yes.
So you can say that it's tension or you can say that it's pressure. And so in either cases, you have osmotic pressure inside of cells and you have some kind of confinement pressure inside of fusion. So it satisfies the first criterion. You have to have some kind of pressure in order to do the thing that produces energy.
Two atoms aren't going to just fuse if they're left in a vacuum together. That's never going to happen.
Why does fusion produce energy?
That's it. From a material atomic standpoint,
Sure.
I mean, why does fusion? I think because you are minimizing surface area to volume at the end of the day. It's why does it's a lower energy conformation to smash two blobs together than to have two individual blobs, because surfaces are really energetically expensive. That's the accounting way of looking at it. That's not a very good material atomics explanation, but you're all nature seems to be always trying to minimize surface area.
Well, it's really interesting because you would assume that a single fusion event would then decrease the likelihood that other fusion events happened, right? Because if you send out all of this extra energy and you jiggle everything around you, doesn't that make it harder to fuse things if they're moving faster past each other?
Yeah, fusion requires confinement. It's that's what's really tantalizing about it with respect to our definition from life, is that in our definition for life, you have compartmentalization, which is another way of putting it as confinement, right? You've confined reagents, whether it's these protons or whatever.
It's really interesting.
Right,
And so you basically build up enough pressure that as the heat increases, the space is still confined, and that promotes further fusion, as opposed to just dissipating into the environment. And I mean, it does dissipate in the environment, but slowly. Okay, so I'm convinced. There is a tension /
It's
pressure
half
mechanism.
baked. It's half baked.
I
Like,
mean, I'm convinced
yeah.
enough that like sketchily worked out, it's like you have this outside in pressure where the way that this works inside of mitochondria or bacteria is that the pressure is on the outside and moves to and relaxes to the interior. And inside of stars, it seems like the pressure is on the interior and relaxes to the exterior. So they're kind of inversions of each other. And obviously all of the details are different. So you have this tension, you have a thing, you have a pressure that's being harnessed. The next case is will. Can you make the case for will and like a motivated motion towards some kind of outcome?
I can, but before I get there, I would linger a minute on self-organization and sustainability, or whatever. What was it? Survivability, the ability to persist across time. Replication's a really interesting one too that we should play with in a second too. There is something interesting from all of this. Let's just assume that the stars are powered by fusion for now.
Okay.
There might be something completely out of left field that we don't understand. Obviously, there have been attempts to explain it in terms of galactic circuits with the plasma cosmology. People are often trying on this idea. And, you know, that I'm not going to deal with that right now, but let's just assume that it's fusion. There's a lot of power that is resulting in really intricate organization of the atoms, at least at the surface of the sun. So you see these incredible patternings, which, you know, are usually described as magnetohydrodynamic effects, right? You see these incredible braiding structures. You see these incredible swirls. You see a lot of dynamics, right? Of stable loop structures that then also collapse at some point. You know, when or why, it's very difficult to say. This magnetic connection phenomenon is somehow tied into the production of solar wind. So, which I'm going to make the case for you that solar wind is in some sense part of the communication process if we're going to assume a community of stars in contact with one another.
Sure, but we haven't gotten quite that far yet.
Right, okay.
Because we're still at this question of directed action.
So I'm talking about the energy being directed towards the production of these intricate structures in the entity, the hypothetical entity at this point. I'm like, look, it's using the power that it generates in its, what did we say, isolated, confined. It's confined some ingredients in order to harness power, which it's using to construct intricate structures that appear to be dynamic and far from equilibrium otherwise. So, in other words, it does seem to be a system which, according to our definition, can confine some tension and use it productively to structure itself. And that's a huge part of our definition for life so far. And I also think the community aspect is important too, and that's not made its way into our definition totally yet. But I wanted to show you guys what I'm talking about here with that, if this is an appropriate enough time to do that.
You ready?
One of the consequences of this very intricate patterning of the surface of the sun, which the details are still eluding even NASA from what I can gather, is that you have this very intricately patterned stream of, for lack of a better word, charged particles streaming off the surface of the sun.
But this isn't the one that you wanted to show, right?
This is where I want to start. So this is today.
I see.
Okay, so this is today. See these nice, beautiful streamers. Now, there's potentially information in something like this. What we have here is a periodic motion that evolves over time. So the streamers are not always streaming from the exact same place. However, the temporal nature of it is quite predictable. So the sun rotates around to its given starting point every, 25 days or something like that. So you have this periodicity. This is almost, you can imagine like a strobe light that's shooting out this stuff out into the cosmos. And you might think, okay, so there's much the same way a neuron encodes information temporally by how much it oscillates in its firing. And you have the convergence of different neurons into these modules that are able to eventually sum up to decision making in the organism. You have this basic temporal information generator in the basic floor plan of a star, just concerning its solar wind.
Hey, really quickly, what's the difference between the top diagram and the bottom diagram?
Velocity of the plasma versus density up top.
Density's on top and velocity's on bottom.
Yeah.
I see. Okay.
So, that's pretty interesting. But then you throw in this other ratchet too, which is the one that I brought up on, I could only find, you can't get the history of these, unfortunately, quite easily from the NASA website. But I pulled up this one that somebody captured from 2021 of a massive solar outburst that actually slams into the Earth there. You can see this is, October 29th from 2021. So these chirps are actually sent out by the stars occasionally. Now, that thing's just flying off into interstellar space, from what I can understand.
We don't really know what happens when it hits the shell of the solar system, though, right?
We don't. But what's really interesting is it does seem to be affected by the planets that are in its path. Right? It seems to bifurcate in this kind of interesting way.
It's hard to say. I wish that it rolled a tiny bit longer. But this is also a simulation, right? This is not.
So they've got a bunch of satellites. They've got a bunch of satellites in place, and on a different viewer of this system, if I go back, I can probably find the locations of those satellites.
But it's not like a lot of we're talking about vast cosmic distances with only a few satellites that are.
Yeah, it's a reconstruction for sure.
It's a model, not even it's like reconstruction is a little bit more robust than model, I think, because it's filling in a lot of gaps. A reconstruction is like you take an old painting and you like patch it back together. There's something about the inference that you take from the data points where I'm like, I'm not trying to say that it's not important or worthwhile or interesting. I'm just saying that there's only so much fine-grained detail that you can take about like the planets are affecting it. I'm like, I don't know.
No, I don't know either. I don't know. I actually never thought of that until I just looked at it just now.
It's like it's possible, maybe. I wish that it played out a little bit farther beyond.
The reason I wanted to play with the idea of the planets affecting it was because when we were talking about the Gaian hypothesis, we didn't really have a way for planets to be participating across vast cosmic distances. But if you accept this hypothesis as interesting, that the stars have all of the hallmark features that we would expect from a living system under the definition that we've concocted today, then we go back to that Gaian hypothesis and we're like, well, how the hell do the planets talk to each other? And it's like, well, they at least have some apparent participation in what the stars are doing, which is, of course, a huge part of Olaf Stapledon's fiction.
But you can also say in some way that the Earth is an organ of the sun or is an extension of the sun. And so if that's the case, if you take the Earth to be a product of the sun, I think that if you take stellar metamorphosis, where solar systems are just assembled by the random transit of planets that happen to end up in the same place, then you can't make the case that the sun birthed the Earth, and then the communication that the sun is doing. Actually,
under stellar metamorphosis, so we're talking about Jeffrey's work, basically. Jeffrey Walensky, shout out. Under his metamorphic idea, and there's lots of variations on this, and some of them are actually fairly mainstream at this point. The planets change from one type of planet into the next type, but under Jeffrey's conception, the stars themselves die off and form the planets themselves. So they do give birth to the planets, is all I'm trying to say.
But not the sun that's currently there. Like, our sun would not be our parent. Our sun would be the parent of a different planet. And so that's what I'm saying. So it's like, conventional model says that there's this giant ball of gas, it accretes, you have the sun at the center, and you have the planets orbiting it. And so they are all birthed from the same primordial soup, which then says that if the sun is communicating, it's possible that that communication is on behalf of the planet, and so you don't have to have the planet communicating because they're one and the same organism, but just different parts of it, right? Like the leaves don't communicate in the same way that the seeds and the fruits communicate, right? Like one is actually sending something out, the other is busy doing something else. And so it's like, it's possible, if they are related to one another, that the communications that the sun sends out are on behalf of the planet, and so there's no real tension there.
I think that's closer to Olaf Stapledon's version of reality. So like you can't really understand the influence of the stars until you zoom out on a time scale that's far beyond your measly little Earth life, and then only then are you able to actually see how the stars are influencing. Now, I would make another case too, because part of our definition set was that not only can it organize its own structure, but it can move itself in this choice-making regime, right? That was part of our definition. It can move itself, it can lean towards the sunlight, it can wander towards the chemical gradient, it can choose which type of Taco Bell it likes to eat.
I think that starts to change for organisms that are really long-lived, because like the tree doesn't move.
It leans towards the sunlight, right?
A little bit. It gets changed by the wind, but it happens it's very small changes, and it happens over long periods of time. And I think that it's a different kind of movement than the bacteria that can start at one end of the lake and end up on the other end of the lake.
Yeah.
Do you get what I'm saying? Like, I think that motion it can be motion in the sense of changing your presentation to the world. It can be changing your appearance is also motion. Changing your activity without actual lateral motion in space
chemical
is the same
signaling on the behalf of plants.
Absolutely.
Yeah.
Absolutely.
Well, anyways, I wanted to make the case that there are some, stars, saying that stars move only according to gravity is a non-starter in modern astrophysics. So
wait, you mean, isn't it the default? Saying that stars move only according to gravity?
It is the default law, but it is not evidenced at all in the literature. And so here I would point primarily I would first point to the galactic rotation problem.
But that's not stars, that's galaxies.
No, it's stars in the galaxy. The stars should be orbiting the center of the galaxy according to the same dynamics that any bodies orbit one another.
But I think that it's just full of dead stuff there.
I don't think so. They haven't been able to see the same kind of micro lensing and stuff like that. It could be, but that's not generally accepted. What is generally accepted is that the gravitational dynamics don't seem to work out by and large in the galaxy.
But for the scale of the galaxy, like, does anybody think that gravitational dynamics don't work out for stars?
Yes, and so the case of that would be the production of an explanation for something like what we would call a black hole or a white dwarf, where the only explanation we can come up with is that some new form of exotic matter with so much stuff crammed into one place that it can do the job that we don't actually see that entity doing. And so, yeah, you can say there's black holes and there's dark matter to explain the galactic rotation, and the white dwarfs are exotic, ultra condensed matter to explain those strange peculiarities. But I would say that there's nothing controversial about the statement that basic Newtonian gravity does not seem to explain everything we see in the sky. Far from it, actually. And so that's not in any sense to justify. It's not necessarily evidence that the stars are doing what they want to do, but it certainly leaves the door open. So, we have kind of ticked off most of the boxes of our definition for life, and it does at least seem to open the door to the possibility that the stars themselves should, as Olaf Stapledon writes, best be regarded as living organisms, but organisms which are physiologically and psychologically of a peculiar kind. The outer and middle layers of a mature star apparently consist of tissues woven of currents of incandescent gases. I'll forgive him on the gases thing there. Those tissues live and maintain the stellar consciousness by intercepting part of the intense flood of energy that wells from the congested and furiously active interior of the star. The innermost of the vital layers must be a kind of digestive apparatus which transmutes the crude radiation into forms required for maintenance of the star's life. Outside this digestive area lies some sort of coordinating layer, which must be thought of as the star's brain. It's like the cortex. The outermost layers, including the corona, respond to the excessively faint stimuli of the star's comical environment, to light from neighboring stars, to cosmic rays, to impact of meteors, to tidal stresses caused by gravitational influences of planets and of other stars. These influences could not, of course, produce any clear impression, but for a strange tissue of gaseous sense organs, which discriminate between them in respect of quality and direction, and transmit information to the correlating brain layer. Should I keep going?
Sure.
This whole book, I could just read this entire book to you guys. It's so fun. The sense experience of a star, though so foreign to us, proved, after all, fairly intelligible. It was not excessively difficult for us to enter telepathically into the star's perception of the gentle titillations, strokings, pluckings, and scintillations that came to it from the galactic environment. It was strange that, though the star's own body was actually in a state of extreme brilliance, none of this outward flowing light took effect upon its sense organs. Only the faint incoming light of other stars was seen. This afforded the perception of a surrounding heaven of flashing constellations, which were set not in blackness, but in blackness tinged with the humanly inconceivable color of the cosmic rays. The stars themselves were seen colored according to their style and age. But though the sense perception of the stars was fairly intelligible to us, the motor side of stellar life was at first quite incomprehensible. We had to accustom ourselves to an entirely new way of regarding physical events. For the normal voluntary motor activity of a star appears to be no other than the star's normal physical movement studied by our science, movement in relation to other stars and the galaxy as a whole. A star must be thought of as vaguely aware of the gravitational influence of the whole galaxy and more precisely aware of the pull of its near neighbors, though of course their influence would generally be far too slight to be detected by human instruments. To these influences the star responds by voluntary motion, which, to the astronomers of the little-minded world, seems purely mechanical. But the star itself unquestioningly and rightly feels this movement to be the freely willed expression of its own psychological nature. Such, at least, was the almost incredible conclusion forced on us by the research carried out by the Galactic Society of Worlds, which you have to read about. Thus, the normal experience of a star appears to consist in perception of its cosmic environment, along with continuous voluntary changes within its own body and in its position in relation to other stars. This change of position consists, of course, in rotation and passage. The star's motor life is thus to be thought of almost as a life of dance or figure skating executed with perfect skill according to an ideal principle which emerges into consciousness from the depths of the stellar nature and becomes clearer as the star's mind matures. This ideal principle cannot be conceived by men save it is manifest in practice as the well-known physical principle of least action, or the pursuit of the course which in all the gravitational and other conditions is the least extravagant. The star itself, by means of its purchase on the electromagnetic field of the cosmos, apparently wills and executes this ideal course with all its attention and delicacy of response, which a motorist exercises in threading his way through traffic on a winding road, or a ballet dancer in performing the most intricate movements with all the greatest economy of effort. Almost certainly, the star's whole physical behavior is normally experienced as a blissful, an ecstatic, and ever-successful pursuit of formal beauty. This the minded worlds were able to discover through their own most formalistic aesthetic experience. In fact, it was through the experience that they first made contact with stellar minds, but the actual perception of the aesthetic rightness of the mysterious canon, which the stars so earnestly accepted, remains far beyond the mental range of the minded worlds. They had to take it, so to speak, on trust. Clearly, this aesthetic canon was in some way symbolic of some spiritual intuition that remained occult to the minded worlds. So he's like, look, there's a lot of pattern behavior here on Earth which makes no sense by mechanical means. You look at a freeway, right, or you look at a school of fish, you look at their motions, and they look like they're being dragged around by some force field. But they're actually, everybody's engaged in these dances consciously and through some sense of duty to the cosmic environment or the local environment or to their neighbors, right?
I think that the point where he says that there's signals coming in is really salient, because I don't think that we're really looking for that. And I don't think that we'd really be able to distinguish what's coming in because it's being reflected off of, what is the shell of the solar system called?
Heliosphere.
The heliosphere. So anything that's reflected internally off the heliosphere would probably be kind of difficult to parse from something that's coming from the outside. And we're also talking about like very long swaths of time for being able to figure out what's happening. But it's interesting because you'd expect that we can watch Betelgeuse flicker, and you're telling me that there's not a different signal that you can tell that's coming into the sun off of Betelgeuse that corresponds to that flicker? You might be able to, but I don't think we have the detectors for it.
There is a stream, right, that we know that the helio sheath folds back on itself and returns to the sun in some sense, right?
Mm-hmm.
So all we're seeing is light from Betelgeuse or anything else. But the stars themselves have an outward-facing sheath of material that is in some sense returning that stream to itself through its poles, from what I understand.
Yeah, it's mixing. Definitely.
It's mixing. And so there's the opportunity for an interaction at the surface of the helio sheath. I think this is what you're getting at, to be relayed back to the star itself. It's at least it's at least possible. I don't know how plausible it is, but it's possible.
And I mean, it doesn't necessarily have to be laterally on the helio sheath. Couldn't it come from straight up? Like there's stars above and below the sun.
Sure.
Right? So it's just, there's a lot of different directions that it could come from. And we have detectors that are looking for signals that are going out because they're really strong. And I think that it's just difficult to find signals that are coming in. But if we were to look, it seems plausible that we would find them.
And you have this very intricate electromagnetic series of structures at the surface that we can see on the photosphere, right? Something really patterned, beautiful, almost chaotic, but the more you zoom in, the more almost patterning you start to become aware of. And so I think that you have, and of course, all of those structures being electromagnetically determined are going to be subject to any kind of electromagnetic pressures from outside, electric or magnetic pressures from outside, not just electromagnetic light or something, right? So you have the ability for something along the lines of structural modification due to perception, right? I'm not saying this is the case. I'm just saying that it seems like we have all the ingredients to genuinely consider that we're staring a life form in the face.
So then let's wrap, and I think plausibly this could be the case. So then where does this wrap to? What does this give us in our sense of the origin of life, or in our sense of life?
I think and I'm not sure how profound this is, but this is where you ended your lecture at yesterday too. And by the way, everybody should check out Nastia's lecture. It's on our Demystify Sci Lectures channel.
And Olaf Shiloh's lectures.
I always put my lectures up there every week.
Twice a week?
Twice a week if you want to learn some astronomy or learn what's wrong with astronomy. I think what this is wrapping to is that life, in what I believe is a more robust definition, a more scientific definition, which isn't circular, but it's a little listicle-y, which makes me uncomfortable. It's not perfect yet, but we've laid out some attributes that seem to define life as compared to non-life. Non-living entities don't display these behaviors that we're pointing to, right? And if we are able to look at how cosmic structures, in particular stars today, are displaying these qualities, then I think we can start to think about life as not this rare, isolated, strange occurrence that's just happening on this little rock in the middle of just gazillions of miles of nothingness. But we can start to think about it as a ubiquitous process that that structures reality throughout the cosmos. And I think that it's somehow, a less alienating way to look at what's happening here. It's always seemed to be distressing to scientists that we don't see life anywhere else in the universe. That's right. You hear that all the time. Like Francis Crick spends his whole book basically trying to solve the Fermi paradox. Where are they? Right?
Yeah, and I'm like, it's not the same as biological life, though, at the end of the day. I think that we would have celestial life, we would have biological life, we could have geological life.
It's not DNA and proteins, yeah.
Exactly. And so I think that like begets like enjoys like. And so what we really want is to come back to what you were saying about this harmony in communication is we want somebody that has our experience because we can communicate more easily with that person than communicating with somebody that comes from a totally different landscape of thoughts and ideas. And so when we search for life in the stars, we really want to find life that looks like us because we really want to be able to believe that we're not alone and that somebody else is working on this project. We can exchange ideas with them. We can figure out how to do it better. And that's sorely missing still. But I think that it's plausible to find, number one. And number two, I think that thinking about something like celestial life does help us in the sense of realizing that we aren't that unique. I think that you're right about that. That we,
in a beautiful way. It's not like you're not special. It's like, oh, you're part of something that's everywhere.
Yeah. And I think that this is maybe the most plausible form of life is eternal that I can take, where if life does not have to be biological life, and life can be anything that has this sort of pressurized system that's able to be harnessed for goal-oriented action.
Communication, maintenance, motive force.
Yeah, I'm like, okay, well, so then that makes sense that that's eternal because that's the same sort of, you could probably describe a hurricane by a similar set of qualifications, right? Where
I don't think so.
I mean, I think that you wouldn't be able to have goal-oriented in there.
Yeah.
But I think that you could have a set of characteristics that you say, these are the characteristics that result in a hurricane, and then be like, well, the form of the hurricane is eternal because there was never a first hurricane. They happen. And the same way that, okay, well, there was never like a first life. As long as you have this system, which as long as there's been a universe, you've had this constrained system possible, then there isn't a first life. You might say that there's a first biological life because then you have this question of how does celestial life evolve into biological life? Do they evolve into biological life? Are they part of the same evolutionary tree? Is there something to be said about, we come from, one of your students said something really beautiful, like we come from stardust or we're all made of stardust.
I think it's Joni Mitchell.
That's probably true too.
She's not in the class this year though.
No, that was last year. So there's a lot left to figure out, but I think that it's easier to figure out if we widen our scope and say, okay, we're not just limited to what happens on this little rocky planet in 4 billion years. We think about it in terms of stars and planets and biology and the community of celestial objects that are all impinging on each other. And then I think that it starts to become somehow more meaningful of a study than just how did chemistry turn into bacteria.
Yeah, and like, what's our goal, like, with science, right? I mean, obviously science is technologically useful, blah, blah, blah. But like, we got into science because we wanted to understand how the universe works.
I actually literally studied biology because I wanted to understand what life was.
Yeah, I straight up got into all of this because I just wanted to know how things work, right? And honestly, I think that in some sense that's the attraction to a religion in a primitive way. It's like you just want to know why do we exist? Like, what is happening? What's the point of all this? And so, like I said at the beginning, I don't think science can answer that for you, but at least we can widen our possibility space to include things that would get closer to answering that,
Definitely.
Which is being a part of a community that's not just limited to a rock in the middle of outer space.
And the next time that we do one of these conversations, because I think that we can probably wrap this pretty safely here. I think it's a good pin to place. I want to talk about fields theories of consciousness, Because I think that this community aspect of multiple life forms impinging on each other to create an evolving system and there being life everywhere is somehow intimately related to the phenomenon of consciousness. And I have ideas about that.
Yeah, let's do that. That sounds fun.
Yeah.
Maybe we can read some Spinoza finally too.
Okay, that's a good idea. Let's do that.
Yeah.
All right. See you guys next time.
Yep. Bye, buddy.